I'm gonna shed a light on a concept law of conservation of energy. What does it deals in? It deals in energy, everyone. And it has an official statement scripted as energy can neither be created nor destroyed, but can be transferred from its one form to another. So today, I'm going to show you some live example to make you understand this statement. Secondly, I'll try to derive a proof for this statement, and finally, we're going to solve some numerical based on it. Dear viewer, I welcome you in classes with a brilliant group of institution, Doha, Qatar. Now let me have a close look in a statement. The statement has two halves, everyone. The first half is energy can neither be created nor destroyed. What is the second half? Can be converted or transferred from its one form to another. Right? Now, for timing, let me skip the first half. For timing, I'm skipping the first half. Alright? And I'm taking the second half right from here. Now, what is this second half is basically dealing in and telling me? It is telling that but can be, but stands here for the energy. So, energy can be transferred from its one form to another form. So, if we see there are different forms of energy we have, right? Like chemical energy, right? Heat energy, light energy, electrical energy, potential energy, kinetic energy, mechanical energy, etc. And what is the specific point about these energies, everyone? The specific point is the energy, this energy which you have seen just now can be converted, can be transferred from its one form to another. Alright, so that's what the second statement is basically telling. I mean, the second part of the statement is telling you that energy can be converted from its one form to another form. Alright, let me have a look. So, this is a process where a bulb is lighting, right? Now, during the process of lighting of a bulb, what you input, what you give the input, right? So, what you give the input is the electricity, right? So, can I tell it that you are giving in electrical energy? You're going to tell me, yes, sir, we are giving in electrical energy. And what it is converting into? You're going to tell me, sir, it is converting into heat and light. Therefore, the brightness come to in our life. Right? So that simple is that right now in this example, we can see that electrical energy is converting into heat and light. So you got me a proof small that basically energy can be converted from its one form to another form. Beautiful. Now let me see in the second part of the example. So you see two guys are cycling over here, right? So if I ask you, what did you pump in? What is your effort? You're going to tell me, sir, muscular. Right? In a pedal of the cycle, what you are putting in? You will tell me, sir, I am pumping in muscular energy, right? And clearly this muscular energy is giving you motion, right? And when an object is in motion, we call it kinetic energy. We'll see in a detail in today's class. But right now, object in a motion will be in kinetic energy, right? For example, particles of the nature, particles of the matter are continuously in motion. So they are having kinetic energy. So you got me that energy possessed by an object due to its motion is said to be as kinetic energy. Good. So let me have a close look once again. So you are applying what? You are applying muscular energy which is converting into kinetic. Though you have a very detail of the energy transformation. Let me come again. So the detail of these energies are muscular is converting into potential, potential is converting into kinetic, and kinetic is converting into heat energy. So, but I'm gonna take the visibility which is visible right now here, that you are applying muscular energy which is directly converting into kinetic energy. All right. So you got me that in the two examples just now we have gotten the first one and the second one, that energy can be converted from its one form to another form. So we got the second half. Basically it is telling me that can be converted from its one form to another. Transfer or convert is the same thing. It is giving me that energy is transformation. Energy is transformable. All right. Now let me have a look in the first statement. What is the first statement is? Energy can neither be created nor destroyed. So this energies which is converting, we cannot create it nor we destroy it. All right. Now to teach you this, to explain you this, I need to go with the derivation. All right. And to derive this, I need to know two energies in a detail. The first is kinetic energy, which we have already did, and second we're gonna see potential energy. All right, so what I'm telling you is very clear. To go with this first statement, all right, energy can neither be created nor destroyed. And to teach you what is kinetic energy and to teach you what is potential energy. So if I get that, okay, I'll very clearly picturize the derivation for this statement. So let me have a look what is kinetic energy. So you already got an idea. The word kine is rooted in Greek, all right, and the meaning is motion, all right. So what is kinetic energy then? Kinetic energy possessed by an object due to its motion, all right. Energy possessed by an object due to its motion is the kinetic energy. Guys, it has an expression. What is that expression? Basically EK, all right. K on the base, K stands for kinetic, E stands for energy, is equals with half of mv square. Here you're gonna tell me, sir, what is m stands for? Mass, all right. What's v stands for? Velocity. So I'm that clear to you that kinetic energy is an official statement and a mathematical expression, right? That's a statement for you and this is the expression for you. Kinetic energy is half of mv square, and any moving object in this planet will be having kinetic energy out of the planet as well. So let me see what is potential energy. Now the potential energy basically tells you that energy possessed by an object due to its position. So you change the position of an object in such a way, all right, it should get an energy in it. Now that energy is potential energy. For example, see the apple on a height, all right, the apple on a height, I'm taking it like that. So in this height, all right, the apple is getting potential energy. In this height, the energy is stored in other way. The energy is stored in this height is in the form of potential energy, everyone. All right. Now this object on a height, the apple on a height, will be having potential energy, and the definition is clearly reflected. It has a mathematical expression EP in the base. P stands for potential, E stands for energy, is equals with mg and h. That's your formula. So you're gonna tell me that here, sir, what is m stands for? I'm gonna tell, sir, m is mass, right? What is g stands for? G stands for acceleration. So I'm writing it like that. You need to make it full. Okay, acceleration due to gravity. Perfect. What is h stands for? You're gonna tell me, sir, h stands for height. All right. So energy possessed by an object due to its motion right now, due to its position right now, due to its height, all right, is the potential energy. Mathematically EP is equals with mgh. So let me have few close look in few of a condition, all right. So first condition is like if. So first condition is like if I take velocity of an object 0. What I am taking here in is if velocity of an object is 0, if v is equals with 0, what gonna happen to the kinetic energy? So kinetic energy is because of motion, right? So if there is no motion, velocity is 0, there should not be any kinetic energy. So mathematically how you will take it? F into m into value for v, you will put in 0, and what's your answer? 0. Right now I'm standing in front of you like that, and I ask you what is my kinetic energy, or you are sitting on the other side, I ask you what is your kinetic energy. You're gonna tell me, sir, our kinetic energy is basically 0 right now. Why so? We don't have any kinetic energy. Why so? Because we don't have velocity. Is it depending on velocity? I'm gonna tell you yes, sir. Now let me have a second case for potential energy. If I ask you that if height of the object is 0, in this entire formula, if I'm taking height of an object is 0, what gonna be is potential energy. So you will tell me that it will be mg into height, right? So m is constant, g is constant. What is the height? 0. So the entire answer will be 0. If I consider this apple in this height, all right, what is its potential energy? You're gonna tell me that, sir, its potential energy will be 0. So keep this in note that if velocity is 0, kinetic energy is 0. If height is 0, potential energy will be 0. All right, we'll have a use of that, so please note it. Okay, let me have a look in this picture. Like this apple is falling from a height. All right, now in this air, the position which I consider the apple is on the air. In air, apple will be having both the energies, right? It will be having kinetic, it will be having potential. Potential is due to height, kinetic is due to motion. Understanding? All right, get this in note as well. Okay, so if you got this very clearly, kinetic, potential, and this part, let me see our derivation. Okay, derivation for law of conservation of energy. Now listen to me very carefully, that I will consider three positions as you are seeing: position A, position B, position C. So position A for this object, all right, let this object be having mass m. Let this object has a mass m. Okay, position A for this object, position B for this object, position C for this object. Position B will be in air, whereas position C will be on the ground. All right, so let me have a look. Position A, there you go, position B, and that was your position C for the object falling from a height. All right, so you took three positions for the same object falling from a height. Position A, position B is in air, and position C is about to hit the ground. All right, what you need to do here? For the first position, I will ask you to calculate the potential energy. What is the potential energy? It will be a question mark. Second, I ask you what is the kinetic energy. It will be a question mark as well. And third, I will ask you what is the total energy. Okay, so your task is very simple. I have got three positions, A, B and C, and what you need to do, you need to find out potential, kinetic and total energy. Do you need to do the same for here? I'm gonna tell you yes, you have to do the same thing. All right, so let me figure out. You need to find out what's the potential energy here, you need to figure out what is the kinetic energy here, and you need to find out what is the total energy here. So what you will do for this position, you will do the same thing. You need to find out kinetic. You need to find out potential. You need to find out total energy. So total energy will be sum of potential and kinetic. I guess I am making a very clear picture. Now once you solve this beautifully, you're gonna see your statement is getting proof, right? Energy can neither be created nor destroyed, but can be transferred from its one form to another form. That will be beautifully picturized. Let me see. To derive this, guys, I'll take three different heights. All right, let me consider this height from here to here, right from the base up to here. Let me consider its h. Okay, during its fall in position B from this point to this point, let me take it x. All right, then see, if this is h, if this is x, what gonna be this? You will tell me this will be h minus x. All right, so you are getting me. I consider three heights. This is the first height, this is the second height, and this is the third height for the object. Of course, it should have. So that's what you are writing in the introduction. Total height should be x. In position B while falling, it is x. All right. In position C while falling from here, it will be h minus x. You can do it, I know. So let me see now next. Potential energy, what's the formula? You will tell me m, you will tell me g, and you will tell me h. That's the formula. Now for this position A, I am doing for this position which is A. What is the potential energy? Is m. What is the g of it? Constant. What is the height from here to here? You will tell me h. So this is exactly your potential energy. The formula itself is the energy. All right. Next one. Kinetic energy. In this height, you will tell me, sir, the kinetic energy will be 0. Now tell me how it happens, sir. How kinetic energy in this height will be 0? See guys, the object is in this height, right? The object is in this height. In this height, the object didn't have any velocity. What I told you the condition, I let the object allowed to fall from this height downside. So in this height, it didn't have a velocity. So what we did in a previous slide, that if there is no velocity, entire kinetic energy will be equals with 0. I guess you are getting me very properly. Here velocity will be equals with 0. Done. So what is the next? Next is total energy. What you will do to get the total energy, you will add both potential plus kinetic. All right. So what is the potential? You will tell me mgh. Potential is mgh. What is the kinetic? Is 0. Kinetic is 0. What's the total energy? mgs. This is it. How cool is that? It's very easy to figure out, right? So you figured out kinetic, potential and total. Do the same thing for here. Okay. Once again, we'll put the formula mgh. Once again, you'll put the formula half mv square. Okay, so let me start. So m is the mass, g is constant, right? So potential energy for this height, for position B, guys, the height will be h minus x. You can see in a picture, relate it. Okay, so what I will do next, I will multiply here mgh minus, I will multiply this like that, mgx. Okay, now let me solve for the kinetic. So when I was trying to solve for the kinetic, I have a small problem here. What is my problem? I don't know the value for V. I don't know the value for V. What should be the value for V? I don't know. Understanding? Why? Because for an object falling freely, in this case V was 0, right? And start falling. So when it start falling, it start getting a velocity. And what is the specific thing about velocity? An object falling from a height, the velocity will be keep on increasing, everyone. So before I find out the kinetic energy, I need to find out the velocity. All right, hope you guys are getting me. Let's see. Now to find out velocity, which formula you gonna apply? So I'm taking it here. Okay, I'm taking it here. You will tell me, sir, for an object falling downstairs, like that from this height, right? U will be 0, correct? So what is the formula? 2gh is equals with v square minus u square. Okay, so you will take 2 into g into, now what is the height in this position? So you might be telling me, sir, h minus x, because for this position potential height I took h minus x, but there is a twist now. There is a twist now. What is the twist? Height I need to take this one, x. For this position, this is the height for potential. Mark it. What is the change? For this position, this is the height for potential. I took h minus x. For this position, height for kinetic will be x. So I'm taking it x. Now, biggest confusion in your life. Sir, why you did that? So I'll tell you, definition itself is the answer. Okay. I told you what was kinetic energy is due to the motion of an object, right? So in this position, object was motion from here to here. So this is the height. Okay. And what I told you, the potential energy, energy possessed by an object due to its position. Right now it's due to its height. So in this position, what gonna be height? This will be height. In this position, what gonna be height? This will be height. Okay. So you are relating it in very simple word. Okay. Whenever you take for the kinetic, upside to downside, because the object was in motion, right? And whenever you take for potential energy, height you need to take downside to upside, because it is due to the height on a particular position is h minus x. All right. So now I got the v square value. Okay. Mark the twist very properly. Potential energy height h minus x, kinetic energy height x. This it. Okay. Nothing rocket science. Now put this 2gx. So I had to put now 2. All right. G and x. V square value, I put it here. V square value, all right. There you go. Okay. Now clearly you can see I can cancel 2 and 2 gone. What's your answer? You will tell me, sir, my answer is mgx. Okay. So you got potential energy is this one. You got kinetic energy is this one. So what you will do? Total energy left over, right? So what is the total energy? Sum of potential plus kinetic, right? Very good. So what was potential? This is the one. So I'll write mgh minus mgx, right, plus kinetic is this one, mgx. Can you see something cancels? Some values cancels? Yes, sir. Both are gone. What's your result? You will tell me, sir, my result is still, I'm getting mgh. So have a look. In this point also, total energy is mgh. In this point also, total energy is mgh. Basically, it is deriving the first part of the statement. Energy can neither be created nor destroyed. Hope you can relate it, but when I solve this part, the picture will be that clear what I am trying to explain right now is. Okay, you do the same thing. You find out the potential energy, you will tell me mgh. So what is the height in this particular position? In this particular position, height was h minus x. In this particular position, height is 0. Okay. So what you will do? mgh into 0. Your entire answer is 0. So here now potential energy is converting into 0. Height in this particular position is 0. All right. Now let me have a look for kinetic. So you will tell me kinetic energy is equals to, sir, half of mv square. So when I was doing, I got the same confusions, the same problem. What is my same problem coming out? My same problem coming out is the v square. So for an object falling freely from this height to this height, object was falling freely from this height to this height downstairs, right? U is always 0. Okay, first case. And the second case, what is happening with the velocity? The velocity is constantly increasing. In this point, what you have got the velocity, it won't remain same in this point. Why? Because keep on changing. That's what the rule says. It's a sigma rule, right? So it keep on changing. Now see very properly. So I need to find out the velocity for v square now for this point. And what you will do, you will go with the same approach you have did here. So let me do this same approach over here. Okay. So you will go with 2gh is equals with v square minus u square. So clearly, similar as here, u becomes 0 for an object falling downward. Here also the u will become 0. So I'm taking off this u, what left out? And the math is here right now. G is constant. Height, what is the height now? For this point, what is the height? You will tell me from where the object was in motion. You will tell object was in motion from this point up to here. So from this point up to here, this is the height. So h is the height, total height, v square. From this point up to here, this is the height. All right, check the height once again. Check the twist. For this, at C, for this point, potential height is 0. Energy at this point. Kinetic, you need to check from which part it is in motion, from here to here. Which point from here to here. So this is the total height. Okay, so in a very clear picture, you need to take care of the height. And I will give you a trick of it. Whenever you calculate for the potential, take the height from downside to upside. For this point, you took this one to this one. Whenever you do for kinetic, for this point, upside to downside. There you go. A trick. For this point, what is the height for potential? Down to up. So 0. Okay. For this point, what is the kinetic energy? Height from this point to this point. So S. So H. That's a trick for you. Okay. For every particular point, kinetic height, upside to downside. Alright. Potential height, downside to upside. Alright then. So you got this. You will put it over here. Okay. So I'll do it for you. So you get 2gh. So clearly 2 and 2 is getting cancelled. Now what happens? That will be equals with mgh. Correct? So in this point, this is your kinetic energy. Alright. So what is left over? You will tell me, sir, I will figure out the total energy like that. So let me figure out. You will tell me that, sir, total energy is the sum of what? Potential plus kinetic. What was the potential? Your mark if you want to study. I hope everybody will study. So what is the kinetic? You will tell me mgh. So what is the total energy once again? Mgh. So this is it. This is it what you need to do. Every point you find out kinetic energy and potential energy and total energy. Okay. And you basically got the derivation very properly. Let me find out the conclusion now. See. In the every point, what is the total energy value comes? Mgh. The total energy value comes mgh. The total energy value comes mgh. Energy can neither be created nor destroy. First half. Okay. Second half can be converted from one form to another. Have a look. In this height, what is the potential energy? You will tell me mgh. Okay. What is the kinetic energy? You will tell me. Have a look in this part. Kinetic energy is mgs. What is happening? Potential energy which was mgs. Now, kinetic energy which is mgs. Is it converting potential to kinetic? Yes, sir. How about this? In this point, kinetic is 0. Now, in this point, have a look. Potential is 0. Kinetic was 0. Potential is 0. Is it converting? You're going to tell me, yes, it is converting. Okay. I guess I made a very clear picture of how energy is converting from one form to another form and cannot be created nor destroyed. So, if you have a look in like this, in every point you see potential energy was different. Just have a look. Here it is different. Here it is different. Here it is different. Every point kinetic energy was different. Have a look. Here it was 0. You can clearly see it. Every point kinetic is different. But what is the total energy? It is remaining constant. Mgs, Mgs, Mgs. I guess you are relating it that energy can neither be created nor destroyed but can be converted from one form to another. Please learn this derivation properly. Okay, it comes for 3 marks. Now, finally, let me have a look of the numerical. How to solve this? An object of mass 40 kg, everybody. An object of mass, how much? 40 kg is raised to a height. This was a 40 kg mass. Is raised to a height of how much? You will tell me, sir, it raised to a height of 5 meters. I'll give you a hint and you solve it in home. And someday when we meet, you let me know that, sir, I basically did. So mass is 40 kg. All right. Is raised to a height of 5 meters. Now, what is the potential energy? And to find out potential energy, you will tell me, sir, I have a formula in my life of finding out potential. EP is equal to mgh. What is the mass? 40. We'll put 40. What is the value for G? Not given, so you know it constant. What is the height? You have already 5 meters. There you go. Finish. You got the answer. Okay. Multiply everything. Get the answer. What is next? If the object is allowed to fall, find the kinetic energy when it is halfway down. So now halfway down, I need to find out the kinetic energy, everybody. Halfway down, I need to find out. Halfway down. So in this part, half. I need to find out kinetic. EK is equal to, what's the formula? Half mv square. So this is your formula to find out kinetic energy. Now have a look. Do you have the value for velocity here? No. If you don't have, what is the approach? You can relate it. Now, sir, I will go with 2gh equals with v square minus u square. Did you did in the derivation? Yes, we did the same thing. Now find it out. 2 into g value how much? 9.8. Height you will take 5? No, sir. Half of the way. Half of the way. Kinetic energy upside to downside. So it will be how much? 2.5. I guess you can relate me. Why 2 point? This is total height is 5. So this half of the way upside to downside will be 2.5, right? Equals with v square. Now this v square you will put it over here. That meaning you will make half into mass is 40 into v square is the entire value. 2 into 9.8 into 2.5. You will cancel 2 and 2 gone. Multiply all this to get the kinetic energy. How cool was that? Okay, so I guess you got me that clear about the concept today. Okay, as I told you that I'm gonna derive, I'm gonna show you example, and finally I'll show you some numerical based on this. I did solve you one numerical on it. Okay, so hope you understood. Okay, what we did, energy can neither be created nor destroyed, but can be converted from one form to another. We have seen an example where energy is basically converting. We have seen a derivation very clearly. It is picturized that energy is converting from one form to another form. All right, that's the proof for you. It comes with 3 marks. And finally, you have a numerical, which is very important. All right, so I will see you in another video. Till then, take care.